So let's go ahead and get started. My name is Brian Mitchell. I'm a program manager on the product group team that builds Azure Data Lake and HD Insight. And today we'll be talking about architecting robust big data solutions. To me, this means two different things. One is what it means to be a robust big data application and thinking about why you're building applications around big data, why you're collecting big data solutions and what you're trying to do there. And then secondly, what it takes to actually build a robust architecture for your big data application. And we're gonna go through both of those and kind of talk through them, mostly about the latter, but we'll start off about the former because I think it's really important as we think about big data, we need to always be thinking about why we're building it and how we can solve our business users' problems. So today we'll talk a little bit about understanding our data lake positions and our strategy. We'll talk a little bit about our Lambda architectures. Who here has heard of a Lambda architecture? So about a third of the room. So that's good that I spend a little bit of time of defining that. And then we'll compare and contrast a lot of similar services as we go through. So one of the feedbacks we often get from our customers is, okay, I just noticed that you have 3 things in Azure that do relatively the same thing. Please give me advice on which one I should use. And you know, the answer, of course, from the consultant's point of view is it depends. And what we'll try to do in this session is talk about why it depends and start with the questions first to get to the answers of which of the services that one should use. I guess that echo is just natural in this room, so please bear with me. All right, so let's talk a little bit about the big data evolution. And the way I see it is that we've kind of come to a place where originally, big data was designed to solve really large batch problems. And oftentimes, when customers first start looking at Hadoop or other big data tools, they're trying to do that, exactly that, which is, I have this large problem, large batch, I need to solve it, and that's really helpful. And there's a lot of good solutions for large batch, but the reality is that as big data has come along, people have asked that these big data solutions become more like what you've expected or wanted to aspire to on-prem, which is more real-time architectures, right? So being able to throw in real-time solutions alongside batch so that you can see the data as it's coming in and actually make, the business users can make some decisions on that real-time data. And then finally, as we've started getting real-time and batch data in, people want to aspire to be able to do predictive data, right? So be able to actually do machine learning within your big data solutions so that you can do batch real-time machine learning and provide an application that provides some real robustness to your end users and really kind of provides them the guidance that they need. So let's start off with some examples real quickly. Here's some customer examples that are using Azure and HD Insight to solve some specific problems. One is from a data sandbox point of view. Virginia Tech is using HD Insight to house genomic data. So this was a large batch problem from their point of view in that they had petabytes of data that they wanted to take a look at to be able to sequence genomes. And when they were doing that on-prem, they would be able to do 1 sequence of genome per every 2 weeks. And when they moved to Azure and they used the bursting of HD Insight to be able to scale up their clusters, they were able to get to a point where they were able to do 20 sequences of genomes per day. At the same time, they were able to save costs. They were able to scale up elastically when they wanted to do any of their testing, scale it down or shut it down when they were done. And they found it very useful to be able to use those services to do that. Other companies want to do something that's more, I would say, almost prosaic in that from a BI point of view, being able to, with rather large data, be able to kind of move that data through a system in which you can use big data tools like HD Insight to churn through the data and then put it onto something like SQL database so that you can have some Power BI reports that run something. But the business use case of having intelligent buildings is rather useful. And we have multiple customers coming to us, talking to us about how can we use big data and analytics and streaming data to really understand where we can save energy costs within our buildings. Because for a lot of companies, whether or not it's large universities or hospitals, or large companies like Microsoft or maybe yours, or even companies that manage malls and strip malls and other buildings for other companies, there's lots of companies looking at, if I could reduce my energy cost by 10, 20%, I can make some significant savings. In this case, Carnegie Mellon was able to use HD Insight, SQL Server and Power BI to get to a point where just through some BI capabilities, they were able to reduce their energy consumption by 30% without any of the extra streaming or machine learning and stuff like that that you would come to, that we'll talk about also. And also there's another example of the streaming platform of these Xeos tablets that you'll see at many American restaurants, like Chili's, for example, where they have these tablets that sit on your table. Xeos uses those tablets as you click into them to kind of explore maybe the menu or play some games. In real time, they're sending that data back. It's going through some machine learning APIs, and it's being returned back with trying to give you better ideas of coupons or giving it coupons and stuff that it can serve up to you based on what you're looking at. So if you're looking at the appetizers for a long time, possibly, it could serve you up a coupon for an appetizer to really kind of get you to bite if you haven't chosen one yet. So this is an example of a streaming platform. All these kiosks are hooked up to Azure Machine Learning. So it goes out, it pings it, comes back, and they get those results that's back. And they have an application that's running in real time. Before we jump into things, one of the things we can do is kind of look at getting your mind rolling about what a robust application might look like from your point of view. So I'm going to show you an example of a financial services app. And this is a demo app of something that we've done for other companies, pretty close for other companies. So here we can sign in as a financial advisor. And the scenario here is the financial advisor has the ability to kind of look at his entire portfolio at once and be able to see kind of what's going on. And in this case, what we have is as you'll see over there in the news, Contoso, we'll use Contoso as the example, has an earnings dip because of irregularities found in their carbon dioxide emissions. So the financial advisor wants to know really quickly, okay, which of my clients could possibly be tied up into the automotive industry a little bit and might be exposed to this particular news problem. But what you can see here just on this one app alone is and data update is pending. That's okay, we should be able to continue with the demo. What you see in one app though is a kind of a combination of all three of those things that I talked about. So at the top, the markets are closed right now, but during the day, those markets would show that the streaming data coming in from the Dow and NASDAQ and what have you. So you have some streaming data going into one app here. You also have some data coming in from some event hubs and streaming in for your news and videos over there on the left, along with the stock quotes. But here in the middle, what we also see is we see the ability to understand my client list and how they're performing. And so this is more typical transactional data that's occurring on my client list and their actual current exposure to the markets. And then over on the right, you can see some additional information. But if I want to go into the client list and instead of looking at all sectors, I can look at automotive, I'll see that I do have one client there that has a fairly large exposure to the automotive sector. And in fact, his portfolio is down. And I can click into him to get a little information about him. And that brings up this particular client's information. Now I have that streaming data still across the top. I also have some CRM data here around him, around Ben Andrews and his age and his phone number and what have you. I have his transactional data down here, but I also have some big data information that's coming in from over here on the right. So here's some customer KPIs. So that's more typical business intelligence data coming out of that. That's really kind of looking at, over time, what is his performance and his savings goals and what have you. But over here on the right, I also have some machine learning data. So my customer lifetime score, his churn score, his risk score, based on everything he's ever done with our corporation. And so that might give me an idea of his churn score is actually pretty high right now because of his exposure to the market. And I could even dive into there, double click on it, and that will actually bring me into a Power BI report where I could see some more information about him. So in this case, what we're seeing is the ability to, in one app, kind of bring everything together from multiple places. So don't think of when I'm doing big data, it's only for data scientists, or it's only for these really robust big data reports. Think about how you can integrate big data solutions and the things like machine learning and streaming right into your business applications, because that's where your customers, that is your users, your business users, are going to find the most use of the applications when you're able to bring it right back into the applications they use every day. And as typical, the demo gods are not with me because of connectivity. I can go back out and take another look at this from a different user's perspective. And this user is Jeff's manager. So this is actually the manager of the entire solution or the entire office. So he has multiple financial advisors underneath him, and he can take a look. Again, he has that streaming data across the top, but he also has some machine learning information coming over here on the right when he can start taking a look at things like suspicious trading or churn risks also. So he could dive into, out of my financial advisors, who's doing some suspicious trading, and be able to drive into that to see some additional data. I'm going to give this 1 second, and then I'm going to go on. All right. Anyway, that should give you an idea of when I talk about robust applications using big data in your everyday, day-to-day applications. That's kind of where I'm trying to go with those kind of conversations. But let's talk a little bit about architecting solutions like that and how we go about doing that. And that's really my day job and the kind of things I hope to talk about over the next hour. So a lot of questions I get from customers tend to kind of fall in some of these baskets. I get on conversations pretty much daily with customers or account teams that want to answer questions like, can you take a look at our architecture and tell me whether or not this is right? And part of the reason why they do that is because there's multiple choices that they can make within the architectural decisions. And they're not real confident on whether or not they should choose something like SQL DW or Spark to do my interactive on the back end, or should I use Event Hubs or Kafka to bring my data in? And so we'll kind of walk through some questions to kind of get them to where their answer is. And so that's one of the questions we also get. So that kind of goes to the second one there, where we get a lot of product X versus product Y. And then sometimes customers go down a long road. They implement quite a few things in development. They get to the production stage, and then we get a call that is basically, I'm ready to go to production in a couple weeks. We've been working on this for 6 months, and now that we're putting more and more data through it, I'm not really sure that I chose the right things. Can you take a look at this and give me some guidance? So those are kind of the three buckets I put the questions I get into. And that drives to really kind of some core principles that I usually talk to customers about when it comes to building these kind of solutions. And those core principles are, one, in the cloud, we need to decouple the data bus. And I'll talk a little bit about that. We'll talk about building for the Lambda architecture. And then we'll talk quite a bit about choosing the correct tool as we kind of go through that Lambda architecture, through all the different pieces. And then finally, we'll talk quickly about the importance of managed services. All right, so decouple the data bus. So what do I mean by that? Let's take a step back and talk about what that means from a traditional standpoint. Traditional Hadoop, and what traditional Hadoop looks like. When you build a cluster on-prem, you have to scope out the cluster size, kind of guesstimate way ahead of time what you think it's going to be based on the kind of data ingress that you're going to have, the kind of number of users you're going to have, and all that. You have to go buy it all. You have to build it and configure it, start administering it, and then start having developers add data to it, and then somebody else starting to add queries. That can take literally months to get up and running before you're even ready to really start running an application. And that's all fine, but what happens if you get it wrong? You need to go back and re-estimate it again. So traditional Hadoop might start off with, you might build this cluster, a 2-node cluster right off the bat. On day one, it has 0 CPU and no data in it, but then you start adding data, you start adding users and queries, you start adding ETL to it, and maybe a half a year later, you get to the point where you're getting relatively full from a storage standpoint, but your CPU is actually not too bad. So you need to look at your cluster and go, okay, we need to actually expand our Hadoop cluster and think about it. So what do? We go and double the size maybe. We now have a lot more room for storage, but and our CPU percentages come down, and now lots of users can come on board. We can start adding more queries, more ETL. People really start using it because now it's really got everything that they need. You get to maybe day 400 sometime in the second year, and you get to the point where you've added some more data because it's been added every day, but you've added so many queries, your CPU is now actually at the top. You're at 100% CPU at peak, 75% average, and now you need to reevaluate and grow again. So you go ahead and you grow again, day 401. You notice you now have really kind of sparse data across your appliance, but you got your average CPU down, and now everything's all hunky-dory. And this is a process that goes on over time. You'll continue expanding and expanding, and maybe these numbers are more in the dozens or hundreds, but you get the point of how you would grow a typical cluster. In the cloud, when we talk about decoupling the data bus, what we're really talking about is you start with storage, and then you have compute. And we'll talk about what our storage choices are and how we go about doing that. And then you can also have compute. And that compute can come from several different applications sitting in Azure. Of course, we'll have to ingest that in some way, and we'll talk a little bit about bulk ingestion, and we'll talk quite a bit about event ingestion or streaming ingestion. Both of those are really important solutions for your big data application. You most likely need to have both to be really successful in the long run, and we'll talk about kind of how you get to that point. And then finally, you need to talk about discovery and visualization, and they're different. So discovery is what we think of when we think of data scientists having access to our big data and having the right tools and everything that they need to be able to find the data in the big data solutions. And then, of course, you have to have some sort of visualization layer that allows your end users that may not be as savvy as your data scientists or your really, really good business analysts, the ability to use tools like Power BI and Tableau or what have you to kind of visualize the data in the ways that they need to. If you want to throw some names of products at these things, we have bulk ingestion. We'll talk a little bit about that, and event ingestion when we talk about event hubs and Storm. But mostly we'll start off with talking about Azure Data Lake Store and how you go about storing your data in a big data solution in Azure. And then some of the tools sitting on top of it, like Data Lake Analytics and HD Insight, and kind of how do you choose between those. And we'll talk a little bit about Stream Analytics and some of those other choices that you might have with Storm. And then finally over there on the right, we'll talk a little bit about the visualization layer, tools like SQLDB and SQLDW to make the queries for visualization really interactive and very quick, for a tool like Power BI to be driven with. All right, so let's talk a little bit about Azure Data Lake Store. There's been a couple sessions this week already on Azure Data Lake Store. If you haven't seen them, you can go find them online. But what we're talking about here is a new store built from the ground up that is going to come out of public preview this fall into general availability, which gives you the ability to basically have any size of data, any amount of files stored into one account so that you can just focus on your applications and how you deal with the data. So there's no limits to scale. You could put a petabyte of data or a petabyte-sized file into the Data Lake Store if you wanted to, or you could put millions of files into the Data Lake Store into one account. Either way is fine. So you can have petabytes of data into your one account. It has a web HDFS on top of it, so it allows it to interface with not only Azure Data Lake Analytics and HD Insight, but it will allow you to access or interface with HDP or Cloudera, if you want to run your solution in an IaaS fashion. It's really important that you can see that it allows you to store your data in any native format. We'll talk about the native formats in a little bit because I think that's important, along with things like your enterprise-grade access control, encryption at rest, encryption during movement, all those kind of things that you would expect from an enterprise store. And then finally, you'll see that it's optimized for workload performance, analytic workload performance. And what I mean by that is it's optimized for the larger your queries get, the more likely you're going to see a performance difference of it compared to other store options you might have. On top of that store is HD Insight. And HD Insight's been around for a few years, but it continues to mature. We continue to add additional functionality into it. This year we've added Spark, and then this week actually it was announced that Spark 2.0 will be available later on this week for HD Insight, which allows you to be, really use the tools of choice that you want to be able to manage your big data in a typical Hadoop solution. It's all 100% open source from Hortonworks. We work very closely with them to take their solutions and put them into a PaaS environment in the cloud so that you can basically, with just a few clicks, get your clusters up and running in a few minutes. And this kind of managed service discussion is something that I'll talk a little bit about later. And then finally, Azure Data Lake Analytics, along with the Azure Data Lake Store, is coming out of public preview this fall. And it will be generally available, which allows you to, as a job service, be able to run queries using a language called USQL, which is kind of a mashup of SQL and C#, so that you can run big data jobs without having to manage a cluster at all. So if you haven't been exposed to Azure Data Lake Analytics, it's different from HD Insight in that HD Insight, you still have to spin up a cluster and manage that as a PaaS service. But Azure Data Lake Analytics literally allows you to just write your job, which is a SQL job, maybe with some C# extensions and UDOs, and literally with a slider at the top of your Visual Studio environment, basically say, I want to run this job in 10, 50, or 200 vertices, and they will deploy that out to a Yarn cluster for you. It's a shared managed Yarn cluster. Run your job, bring down the vertices, and just bring your data back to your store, wherever you happen to have your output of your job go to. The developer experience for people that are from the Microsoft ecosystem is very natural because it uses Visual Studio and a lot of tools you're already used to. It also allows you to federate across Azure sources. So in this case, what it allows you to do is go out and get data from other sources within Azure. And this is actually probably tip one when it comes to robustness is leave data where it belongs. So if you have data sitting in maybe SQLDB or SQLDW that has a conformed dimension, maybe of your product or users, there's no reason to copy that data sitting over into Azure Data Lake Store or your big data store just so that you can augment your data as it comes through your ETL pipelines. Leave it in your SQLDB or SQLDW, and when you write a query in something like Azure Data Lake Analytics, we can write within our cluster, but then also join out to additional data sources like Azure SQL and VMs or Azure SQLDB. Go get that conformed dimension at query time, bring it in, join it, and then augment our data as we push downstream. Some usage scenarios for Azure Data Lake Analytics. Number one is load, extract, transform, and store. So the idea here is you load your data into Data Lake Store from the upstream scenario, and we'll talk about the upstream scenarios in a little bit. You drop it into Azure Data Lake Store, and then you can use something like Azure Data Lake Analytics or HD Insight to extract the data. So instead of ETL, when we talk about big data, we tend to talk about load it first, and then you can extract it using parallel queries, transform it, and then store it back. So use the parallelism to do your ETL within your big data solution instead of trying to do ETL before you land it into your big data solution. This might seem obvious to people that are doing big data, but it would surprise you how many people or how many customers I go and talk to that are trying to transform data out of the sources it has, because that's what they've traditionally done before they've landed it into a data warehouse. When you're dealing with parallel data warehouses, or when you're dealing with something like HD Insight or Azure Data Lake Analytics, the power comes from being able to say, I want to run this job across dozens, if not hundreds of nodes, right? And so why not do your ETL across dozens of, or if not hundreds of nodes? And in fact, that is exactly what Hadoop in particular and Azure Data Lake Analytics are really, really good at. So use that scenario to do some of your batch cooking. So what does it look like when we actually talk about decoupling data from compute? We can take a look at what it would look like if I started today, now in Azure as opposed to on-prem, and I start off with some sort of amount of data sitting in Data Lake Store, and maybe I choose a couple nodes to run my big data analytics today to be able to do some work on it, do my ETL, land it back in the store, and then Azure Data Factory picks it up and moves it over to SQLDB so I can run into Power BI. In the cloud, maybe my store grows, and maybe my analytics grow a little bit too. They could grow together if they need to. And you can see that they've grown. I'm doing Azure Data Factory, but I've also moved from SQLDB to SQLDW. And so this is kind of the one aspect of the robustness of cloud solutions is the ability to decouple everything from each other. And as your systems, as your needs change, you can change one part of it without affecting others, and that's a really important part of it. So like Power BI, for example, interfaces equally well with SQLDB and SQLDW, so if you need to, you can upgrade from SQLDB to SQLDW as your data grows from an interactive layer, and we'll talk about why SQLDW is really good for the interactive layer later. But as your data lake store needs grow, maybe my store doesn't necessarily grow all that much, but I have more queries, I can go ahead and just continue adding additional vertices to my Azure Data Lake Analytics or additional compute nodes to HD Insight as necessary. And then finally, in the future, as I want to grow from really kind of my robustness for SQLDW loading, coming in the very near future is the ability to do polybase of SQLDW against ADLS to really be able to pull in the data in parallel and really improve the loading of SQLDW from ADLS. So what I'm talking about here is kind of the base architecture of what we call the Lambda architecture. And the Lambda architecture is something that was first defined about 5 or 6 years ago, I believe, by a gentleman that wanted to really describe a world in which we can load data, do batch, but we also need to be able to do streaming within the same environment so that we can provide our end users with the best of both worlds like you saw in that application earlier. So generally speaking, we kind of break it up into 4 layers. We have data consumption over there on the left that we call the ingestion layer. Then you basically usually talk about it into 2 layers through your preparation and analyze phases, which is your speed layer and your batch layer. And both of those are equally important. And you'll usually start, if you're starting off and building a new application, you'll start off by building a batch layer, getting your data into Azure, and then and running your applications to kind of churn through, doing typical ETL jobs. You can use HD Insight or Azure Data Lake Analytics to essentially do faster batch than you're doing today. And that's okay, because one of the pressures you might be getting on-prem is you have your end users who think that they want real-time data, and to them real-time means instead of giving it to me once a day, give it to me once every hour or once every 15 minutes. I call that real-ish time data. And that's okay, and by moving away from your traditional single-threaded ETL solutions on-prem to something where you can get the data into your data sources in Azure and then use something like HD Insight or Azure Data Lake Analytics to do parallel ETL, you can get your batch down to much faster batch processes to where you're down to every 15 minutes or every 30 minutes to be able to get that data into the presentation layer so that your end users feel like that they're getting the real-ish time data that they want. That's step 1. Step 2 is then start adding the real-time, the speed layer on top of that, and then slowly start replacing some of the things that they think they want in real-ish time with actual real-time data while still processing your batch layer. So when you're building this architecture, let's talk about some of the things you need to think about when you build it. Scalability. So you need to be able to scale as time goes on. Every piece of the puzzle needs to be able to scale. And that is from your ingestion pieces to your batch and your speed layers, and then finally your presentation layer. I've already talked a little bit about the scalability on the HD Insight and the Azure Data Lake Analytics side, right? Scalability in the cloud is what the cloud is built for, and how we build our tools is to be able to scale rather easily. When you build an HDI cluster today, if you choose 10 nodes and get it up and running and you run it and you realize, wait a second, that is not big enough for the applications that I want to run. I really need to be running in 20 nodes. It is nothing but literally going to a slider, changing it from 10 to 20, hitting next, letting it wait a few minutes while you spin up a few additional nodes within your cluster, and you're up and running with additional nodes. The scalability in the cloud on HD Insight is built right in. Same thing with Azure Data Lake Analytics. Azure Data Lake Analytics is a job service, so you can run a query once with, let's say you decide you run it with 20 vertices, which is essentially the same thing as nodes within a cluster. It deploys out 20 vertices within the cluster on top of Yarn, and you run the query, and maybe it comes back in 10 minutes, and you're like, that's way too slow. And I really need this job to run faster. So I go ahead and say, next time I'm going to run it, I literally click a slider over and say, I'm going to choose 100 vertices this next time and run it. And the next time it comes back in 3 minutes. That is the scalability of Azure Data Lake Analytics or HD Insight really allow you to handle that. And the cloud, all the tools in the cloud should be able to do that rather well. Resiliency, of course, so the ability to come back when something breaks. Both Hadoop and Azure Data Lake Analytics have those concepts of resiliency built into them. Low latency, of course. So when we talk about streaming, the ability to get data into your solution quickly with very low latency is important, and we'll talk about some of the best practices of how you can go about thinking about that later on. And of course, it needs to be extensible. What I mean by this with the little handshake is that each piece of the puzzle can be replaced with another solution later on without affecting the other pieces. They need to be able to talk and interface between them. They should have the right APIs and kind of data transmissions between them so that when you decide that SQL DB is too small for your interactive layer, you can switch it out to SQL DW without affecting the upstream or downstream solutions. And that extensibility is very important to kind of growing and being robust, because in the cloud and with your big data solutions and with BI in general, you're always going to be growing, you're always going to be adding new solutions, and you need to be able to look at how can I do this without affecting, how can I replace one part without affecting others too badly. And then finally, maintenance and maintainability should be very important. So when you're thinking about that Lambda architecture, you need to be able to choose the tools and choose your tools wisely. So let's talk about the first part, which is event ingestion, which is this left side, which is your data consumption. This is getting data into your solution. Some of the patterns that you'll see generally coming in from things like your business apps, you might have custom apps or sensors and devices, you might have web logs, what have you. There's really two choices that most people are kind of considering at any given time, which are Azure Event Hubs, which is the built-in Azure solution, and Kafka, which is part of the open source community. Today, Kafka is a solution that you would have to build yourself within Azure, but we have multiple customers doing that as necessary. In the future, we plan on adding Kafka as another choice within the HD Insight space, but if you were to choose Kafka, you would have to do that yourself today. And we'll talk a little bit about choosing between those. Once you get those events going through your event hubs or Kafka, usually you're going to pick a stream processing solution, Azure Stream Analytics, Storm, or Spark Streaming are some of the choices that you would have there, and we'll talk about the differences between them to eventually finally maybe getting those events downstream eventually to something like Power BI. And also those events should also land into your big data store. So while you want the events to drive an application like you saw earlier when I showed the financial application, the events were coming in and driving the Power BI report in real time. Those same events were being written back to a big data store so that they can be used later on for larger aggregations and machine learning within the solution. So choosing one of those ingestion technologies, when you choose between something like Kafka or Event Hubs, I have quite a few tables like this, and what I try to do is put some things in bold, I think, that kind of make one stand out over the other. In this case, Azure Event Hubs is really easy to use because it's a managed service. You can get it up and running, and it will scale to just about everybody's needs. I do know that the Event Hub team is looking for customers to push them beyond the 20 throughput units that they have listed down there, because that's just kind of a limit that they've put in place, but they're actually looking for customers to go beyond that, which really allows millions of events per second to come through anyway. On the other hand, if you really have a large application, if you're a really large company looking at doing something like connected cars or some other thing where you're really thinking about millions of events, if not billions of events per day, something like Kafka and building your own solution can be really useful because the throughput is just based on how big do you want your cluster to be. You build a big enough cluster, you can handle enough events to really kind of handle it. The downside of Kafka is the admin costs on top of building it yourself. So you have to build it yourself and maintain it, as opposed to something like Event Hubs is a managed service that probably would, for almost everybody in this room, probably handle the solution that you need. And then after that, once you've kind of gone through that ingestion technology, oftentimes you're going to be choosing a streaming technology. And like I said, there was three big choices. The nice thing about Azure Stream Analytics is that it uses a SQL-like interface. So it has a SQL language that is really stupid simple to set up. When you go into the application into the Azure portal, you literally can quickly tell it what event, where you want to get data from, where you want to write data to, what's the SQL query that you're going to run with some of your windowing aggregations, and maybe join it out to some data sitting into blob storage that might be some reference data that you want to do, and have that up and running within 30 minutes. And then it can, on top of that, it can, of course, scale and what have you. Storm and Spark streaming, on the other hand, are a little bit more complicated to set up. They have some limitations there. But on the other hand, when it comes to being able to really handle any amount of data, both of them are really kind of just depend on how big you want your cluster to be. Additionally, Spark and Storm have huge user communities out there. Especially, both of them actually have huge user communities in the open source arena. If you have a question about how to do something, you can go to Stack Overflow and probably find the answer without having to, write it down and have somebody answer it a couple days later. So there's pluses and minuses both ways there. But I will tell you that Azure Stream Analytics is really easy, and this is kind of the case where if you start with something like Event Hubs and you're dumping data to Data Lake Store and you're just starting a streaming application, one of the things you may try to do is, instead of going straight to Spark Streaming or straight to Storm, start with Azure Streaming Analytics. Don't go build something on your own until you need to. And that would be my first recommendation when it comes to robustness is, there's no reason to, because you can always take that piece out and replace it with another piece later on when you find that it's necessary. A lot of times people want to go to something directly like Spark Streaming or Storm because they've gone to conferences and they've seen lots of good things about them, but then they're much more complicated to run than something like Streaming Analytics, and you may not need all that complication for your solution. When it comes to scaling, if you're using something like Azure Stream Analytics, one of the recommendations that I would make is that in Event Hubs, how we scale Event Hubs is the idea of partitioning your Event Hub. So you partition the data as it comes in, which allows us to basically have partitions that we can access on the egress out of Event Hubs. And with Streaming Analytics, one of the things you can do is you can do a partition by partition ID within Streaming Analytics, which allows us to run multiple queries within Streaming Analytics if necessary, basically by partition ID, so that you could have multiple queries running and that data can then go downstream and land into your ADLS, or all that data can go to another query that then aggregates the aggregation coming out of Streaming Analytics if necessary. Why would you do this? If there was enough data coming into Streaming Analytics and you really need that data to flow through quickly, by partitioning the data out into multiple queries, what you allow yourself to do is to really make sure that that data does not slow down through the process as you may be joining it to other data or other streams, and really just make sure that it gets to that end user report like Power BI or what have you as quickly as possible. One of the things you may be tempted to do with Streaming Analytics, now that it is, I believe it's still in public preview, is the ability to do Streaming Analytics and Azure ML together. So you could do something like take your Streaming Analytics query, and you can, through that sentiment score, you can actually call Azure ML to basically score an event as it comes into Streaming Analytics. So that's really cool, right? So we can score the data before we even landed on Azure Data Lake Store, and then push the data also up into some sort of application, and that application would have all these scored, let's say, tweets or something else going on if you wanted to do sentiment or anything else that you want to do from ML for these events coming in. The downside of that is it takes a while to score an event, right? So the whole point of streaming is for things to come in quickly and not back up through the system. If you're now adding the scoring of events into something like Azure ML, it's now going to have to make a call out to an API. Azure ML is going to have to answer it, figure out what the score is, and send it back. And something that might be just taking a few milliseconds may now triple, quadruple in time, and maybe a little bit slower than you're expecting. So take a look at that, and if that means that your data is coming in slower at the end point that you want it to, or your Streaming Analytics is not performing at the rate you want it to, you may have to, if you really want to do this, maybe the thing to do is go back and do this partitioning so that you can get your data out into multiple partitions, multiple queries, so that you have less data come through one stream. Just something to think about. Or the other choice might be, don't do your scoring at streaming time, land it on Azure Data Lake Store, do your scoring in batch, and then provide the batch scoring into your application later downstream. So let's talk about choosing the data store, and this is going to kind of match up not only data store, but also the kind of batch analytics you would do on top of that. So I talked a little bit about Azure Data Lake Store earlier. No limits to the amount of data you can store, no limits to how long it can be stored or the number of files or the size of any individual file. And it has a really high ingestion throughput, so you can bring data in, out of those streaming applications, no matter how many streams you have up, it's gonna be able to handle it, and then we can scale from, if you're just starting off with a few kilobytes or megabytes today, into the petabytes in the future. And this talks a little bit about some of the technical requirements that you might have for it. Data Lake Store is definitely set up to be secure to prevent unauthorized access. It has its own firewall abilities so that you can basically say, hey, I only want these IP ranges to access my data, and these IP ranges may be from whatever my on-prem IP world is. It also has the typical authorization and access control that you would expect. It has file and folder ACLs so that you can basically give the same kind of file and folder ACLs that you're used to from your on-prem world. And then it, of course, has encryption at rest. We talked about its scalability also. And then down at the bottom, it supports multiple analytic frameworks. So we can definitely do batch on top of it, but it's also built to handle that real-time data streaming coming in with no problems. So for something like Data Lake Store, one of the things that we might want to think about is, what data types do we want to put into it? And this is where we really want to think about storing data natively. So the data coming in, we want to store as it was produced. And that is kind of rule number one of big data, which is if it's unstructured data, let's store it unstructured. Let's not do anything to it at first. And I'll talk about how to place that data within your Data Lake Store in a little bit. But whether or not it's logs, whether or not it's pictures, what have you, go ahead and just store the data because we can do lots of things with it later on, and we may want to come back and do more with it later on. We can also store semi-structured data. So whether or not it's JSON, XML, things like Avro, that's perfectly fine to store those semi-structured data. Then, of course, structured data like CSV or columnar storage like Parquet and ORC are really good choices for big data stores. In particular, seriously consider columnar formats if you're doing HDInsight and especially Hive. This allows, just like SQL Server, allows data to be, columns to be stored contiguously on disk so that you can read columns really fast. Oftentimes, with big data solutions, you have very wide tables, very wide files. And when somebody queries those files, they oftentimes only query a small subset of the columns within that space. In your traditional CSV file or your traditional row-oriented store, we have to read that entire row in to be able to find the columns that we need. By going columnar, it just really allows us to pick out the columns we need, pull them in, do the query, and push on. So it really improves the performance of queries. The downside is we have to convert that data first. So this is a place where I would still say store the data in its raw format first, then we convert it into a columnar store and store that somewhere else within our store, and then access that for the downstream queries later on. And I'll talk a little bit about that. When we talk about the couple of columnar formats most customers talk to us about, ORC and Parquet, ORC is definitely best for Hive. It was built in conjunction between Microsoft and Hortonworks along with the open source community to really make Hive perform much more robustly than it had been in previous times, and we'll talk a little bit about that. It definitely allows for fast execution. It allows for insert updates and deletes on that data. And it's like I said, in the HDInsight and Hive space, I would definitely recommend the ORC world. On the other hand, a lot of Spark Hive loads or workloads or things that are mixed Hive and Spark workloads, a lot of times you'll see Parquet recommended. If you have more questions, especially around Hive, instead of me going into a deep dive on Hive because I don't have time to, I would highly recommend this session that was in the earlier this week from the Data Science Summit. It's available up on Channel 9. When you get the slides, you can always dive into that if you have a lot of questions around Hive. I've talked a lot about Azure Data Lake Store because it is new. It is what we consider most of our customers, when they think about big data, that is where we think that most of our customers are going to be placing their data in the long run. But today, for a lot of customers, Azure Blob Storage might have been where you started with, and maybe where a lot of your data is. And it's really kind of good to kind of compare and contrast the two and where they're good for. Definitely one of the pluses of Azure Data Lake Store I've already talked about is the things like the account and the integration to Azure Active Directory, the file and folder ACLs and all that kind of stuff, the hierarchical file system, as opposed to the Azure Blob Storage. One of the things that makes it really nice right now for everybody is the fact that it's generally available and available in all regions. So Data Lake Store today is in public preview. It's only available in one region in the US. It's going to be in a couple regions here very soon. And then over the course of the next year or so, we'll start deploying out to many more regions around the world. And that one region today, of course, is the US to start with. So there's some limitations for customers there. On the other hand, as we deploy Azure Data Lake Store out into additional regions and after we go GA across the world, we would highly recommend, when you're thinking about analytics and big data analytics in particular, the Data Lake Store in the long run is definitely where you're going to be. That being said, if you're developing a solution in Europe or Asia today, and you really need to get started today, go ahead and start with Blob Storage. We have hundreds of customers using Blob Storage with HD Insight with no problems today. And so there's no reason not to get started there. It has some of the same limitations other cloud big data storages have, in that it has some, it has some IO bandwidth challenges. It has some size constraints where if you have enough data, if you're talking into the petabytes of data, or even hundreds and hundreds of terabytes, you might have to have multiple accounts set up to handle a particular solution. But in most customers' cases, Azure Blob Storage can handle what you need. Going into the future, though, as data sizes continue to grow, as your I/O needs continue to grow, Azure Data Lake Store is definitely the place you're going to want to be. But again, this is a place where you can build an HDI solution, HD Insight solution, today on top of Azure Blob Storage. And when Azure Data Lake Store comes available, you can simply move your data over to Azure Data Lake Store, and it shouldn't change your application in your Azure Blob Storage much, if at all. So a little bit about storing data for enterprise robustness. So one of the things that I often talk to customers about is separating storage by organizational units and/or applications. So this is a conversation that you get into. A lot of times customers will talk to you about, okay, I have multiple organizations that want to store data. I want to be able to, I know I can put everything into one Azure Data Lake Store account. That's great. How do I build them separately? And I don't have a good answer for that today, other than it's okay to build multiple store accounts. I could create one store account for HR and another store account for e-commerce, and I can build them based on the amount of data and the number of transactions they have in each one, and I'll be fine. What's great about something like HD Insight or Azure Data Lake Analytics is you can set them up to access multiple stores. And in fact, because storage and compute is already separated, there's no performance penalty to having multiple stores to bring data into your compute world. So if I'm thinking that I have to separate out data into multiple stores, just go ahead and do that, and then that way you can build people separately. It also allows you to have a little bit maybe more fine-grained access control if necessary. Use time partitioning often, and what I mean by this is customers are oftentimes asking, how do I set up my folders? What kind of structure should I do? And of course, you can have organizational units and application units, for your top level structures. But really, when you get down to the bottom level and you're really talking about accessing that leaf level data, the best way to store that data is oftentimes a year folder, a month folder, a day folder, and then whatever level of granularity you need to get to. This allows you to do partitioning, whether or not it's in Hive or something like Azure Data Lake Analytics, which allows you to really kind of manage your data in a much better way. It also allows, when you start doing partitioning with folders like that, it really allows you to do folder elimination when you start putting indexes and stuff on top of that, so that you're only looking at the data that a particular query is having to wants to look at, as opposed to having to scan across all the data. That goes back to paths should be obvious and self-documenting. In a big data store, if you want to talk about cataloging data for your data scientist access data, of course you can have a data catalog. You might use Informatica. There's all sorts of ways that you can deal with cataloging of data. One of the best ways to deal with this from a BI standpoint, though, is just make your folder paths really self-documenting. Don't try to get too cute with them. I see lots of customers that get really cute with the paths and all sorts of just crazy names and acronyms. And what it means is that somebody new to the organization has a hard time accessing that data. And then, of course, try to get it right the first time because retrofitting after the fact is difficult. And what I mean by that is once you start dealing with storing petabytes of data and having that sitting in a store somewhere, if you decide you want to change your structures, it's usually a fairly painful process to go back through and try and move everything around as necessary. It's doable, but it will cost time and money to get there. So one of the ways I like to think about storing data in something like Azure Data Lake Store is talking to customers about where do you put your data? Because we get this question a lot, which is, okay, I know I can do file and folder ACLs, I know I can put access, but I really want a place for my data scientists to be able to play. I want to be able to put a place where all my raw data coming in from my applications, either streaming or batch, and be able to dump that in. I need some place for my developers to work. And then finally, I need some place where my applications know that the data has been vetted, right? So there's a difference between that raw data coming in that we tell you not to change and that data that we've mashed up with other conform data and vetted it out and made it trusted for the rest of the environment. So the way that we oftentimes look at it is you can create some folder structures that allow your users kind of this kind of space. And this is just one way to do it, just a kind of a seeding of an idea that'll allow you to take it back and maybe do it slightly differently in your environment. So for example, if we had a raw environment in which we had the raw data and we had a staging environment or a development environment, that would allow us to pull data out of the raw area, bring it into staging. That could be where my developers work to really kind of develop the next generation application that the downstream applications might be using. And when I say downstream application, I could seriously just mean just the final result set of my data that I'm going to push into something like SQLDB or SQLDW to drive my Power BI or Tableau reports downstream. So I need a place that I can do development, right, and be able to bring data in and do stuff with it. And then finally, when I'm done with that, maybe some of that data gets pushed out of that staging environment into production, but most likely what they're going to do is they're going to operationalize their work, and that data is going to go straight from raw into that trusted environment. I'm going to have a folder structure such that says only data that falls into here has been produced by my developers and kind of verified and everything and pushed downstream, and my applications are only ever going to take data from this trusted environment. We're going to call this a trusted environment for everybody downstream because they know that this is data that we've worked on. So from a access point of view, when you look at the raw, a lot of times I talk about to customers how that raw environment is a place where only the file applications can write to, but your developers can't write to it. They can only read from it. So that prevents them from changing the raw data that we've set up, and it's just going to keep coming in from whatever upstream sources we have. On the other hand, the trusted environment is also in a place where only the operationalized data flows that I have are writing data to that trusted environment. My developers aren't writing to it, and the end applications aren't writing to it either. Thirdly, I'm going to have a sandbox, and almost every customer we talk to has this idea of a data science sandbox or a business analyst sandbox where they need to be able to take that data out, pull it into some separate space, and this is where they're going to figure out what the next generation analytics applications are going to be, right? So they may try 100 different things and only one of them works, but they need some place to do that. And so by giving them their own place where they can go play with the data, delete it, and what have you, and that's their world, and you don't have to worry about it too much. They have read and write access. Let them go nuts over there. And then when they're done and they figured out that one out of 100 things, let them write that data back to staging. Your developers can operationalize it, and then that data can start flowing through to the trusted environment also. So I'm going to take a breath here and let you kind of look at this slide because this is just kind of setting up the talk for the next couple slides about kind of defining the difference between hot, warm, and cold data. And what I mean by this is they have different characteristics. It's not just a matter of volume size. A lot of times we'll talk about cold data just being, I have petabytes of data and I'm only going to access maybe terabytes of it at any given time. But it's more than that. A lot of times cold data may be that it's really large item sizes and it's just hard to get to in the first place. Its latency could be that we just don't care if it takes a while for us to get the answer back. But the idea is that we want to have different places for different kinds of data. And it's really kind of important when we think about hot, warm, and cold data, where we place that data. So one of the things I've thought about is, what if we took those characteristics and put them on a Venn diagram that kind of helps us kind of understand, hey, depending on whether or not I have hot data, whether or not it's, whether or not I have a request rate needs, whether or not I don't care about how much it costs per gigabyte, whether or not low latency on the left or data volume, and then what kind of structure of data. And this is kind of important also. Is it really kind of, if you go back here and we talk about, I don't talk about structure there, the structure data, is it just kind of naturally just gnarly like log files, or is it something that's more traditional, kind of tabular in nature, CSV or TSV? This gives you an idea of what data store you might want to choose. And this is a conversation that I think is really important, which is just because you're talking about just because you have a new application and you have been affiliated with a couple data stores, doesn't mean that all the data that you have should go into that store. Think about the use case for that data. So if you have data that really has low latency, is fairly simple, or fairly simple, but it needs to really have low latency, you may want to think about doing a cache or some sort of NoSQL database like DocDB. On the other hand, it might be more relational in nature, and you need to have it has high amount of structure. You need to have some fairly high request rates. SQL DB or SQL DW might be right for you. On the other hand, as the structure gets down and it's a little bit colder data, something like ADLS or an HDFS file store might be right. So choosing some of those applications, if you kind of go back the other way, you now start taking a look at things like choosing between SQL DW that has high SQL compatibility, and we'll talk a little bit about it in a minute, versus something like HD Insight that has a little bit higher query latency. This next part, out of all of that though, when you're thinking about your big data applications, the next thing to think about is, okay, I've talked a lot about ETL, I've talked a lot about user queries. A lot of times customers build one cluster to handle the solution for those. And so a lot of times you'll talk to a customer and they'll be like, yes, we have this ETL processes and we think they're going to take about this long, and it's about this much data, and we'll have about this many user queries. What's the size of cluster that I need to handle all of this? And one of the things that I've really been recognizing over the last year or so is, why just one? If you have one of the nice things about moving your big data solutions to the cloud, if you're using something like Azure Data Lake Store, is multiple clusters or multiple applications can access your data, the same data. So why not split your ETL load and your user queries out into two separate applications? And if you start thinking about this, if your ETL load is such that it's going to run for 6 hours a night and you really need to have 40 nodes to be able to do it, and it's going to churn out at 100% CPU during those 6 hours, but when you're done, there's no more ETL for the rest of the day. But your user queries come in and they really actually, while you have a lot of users, you really only need maybe 8 nodes for your particular use case. Why have a 40 node cluster to run 24/7 when an 8 node cluster running 24/7 is all you need, and you could run a 40 node cluster for 6 hours and then shut it down? And that's one of the nice things about the cloud. If you shut that cluster down at night, then you have no cost to you or during the day, because there's no cost to you when that cluster is down. Also, if you use something like Azure Data Lake Analytics to run those ETL processes and jobs, you only get charged for the length of the time the job's running times the parallelism that you choose when you run the job. So you could run Azure Data Lake Analytics to do all your ETL, write all that data back to Azure Data Lake Store, and then have something like Hive or Spark running in a separate cluster to be able to serve up your queries. By changing your workloads, you can also change the structure of those clusters also. So a lot of times when you talk about, if you go back to Rashim's session that I pointed at earlier, and he talks about Hive in depth, one of the things you'll understand is when you build a cluster and you're trying to perform it better for either user queries or ETL, you're going to define a lot of the settings differently between the two. So if you build 2 clusters, you can build one that's specifically for ETL and is highly performing for those kind of batch ETL workloads, while you build another one that is more performant for your more interactive queries. Speaking of interactive queries, let's talk about materializing for that interactivity. So we've done all this ETL, we've pushed it all downstream, we have it sitting in something like Data Lake Store. One of the things that we need to do now is we need to present it to the end users. And right now, in most cases, most of the big data tools that are available aren't great at that kind of interactive environment through Power BI or Tableau that our end users are used to. They've really pushed for not pushing a report and coming back in 5 minutes, but pushing for being able to click on something and get very quick interactions back and forth. And in fact, most business users want to have self-service tools to be able to access that data. So we need to be able to build self-service environments for them. So that presentation layer can look as simple as, we'll get that data into something like SQL DW or SQL database and then be able to serve that up into Power BI. All right, so what's SQL DW? Well, how's it different than SQL database? Well, first of all, SQL DW is a parallel data warehouse system, right? And it is built so that it can grow and shrink and pause in seconds, a lot like the clusters that we talked about in the HD Insight world, in which if you decide that, hey, this 12-node SQL DW that I have isn't big enough, I can double the size and really kind of spread the data out and be able to access those queries. What's also nice about it is it really is just gives us the ability to scale our compute and storage separately, so that as we need more compute, we can scale that up with more nodes. And it also does the transactional SQL queries that you're used to in SQL DB. You can now have transactional T-SQL queries against SQL DW running in some fairly large systems against terabytes and terabytes of data, and things like Power BI and Tableau just work against it. So that allows us to do the analytical workloads on top of it, basically SQL on SQL, all using the same SQL constructs that your report writers already know today. So when we compare data lake and data warehouse, why would you do one over the other? What is the difference? I get that question a lot. Okay, I have data lake, whether or not that's HD Insight or Azure Data Lake, or I have a data warehouse. Where do I put my data? Well, the reality is that you use them both. They're complementary, right? So data lake allows you to do schema on read. What that means is you write your data to disk, and you worry about applying a schema to it when you query the data, right? Whether or not you're using Azure Data Lake Analytics or you're using Hadoop, when you write your query, you define the schema over the top of it. That way, you don't have to worry about defining the schema when the data comes in, the data changes. You can still continue writing data without having to have a lot of developer overhead. On the other hand, a data warehouse is a schema on write, something we've traditionally done, build our star schemas, which can take some time, defining all the conform dimensions and what have you. But that schema on write world gives us that optimization for I/O and CPU. It gives us a lot of reusability. It gives us some simplicity for end users. And it also gives us, because of the ability to do things like indexing and what have you, a high user concurrency. So that we get that predictable query performance, which our end users come to expect. On the other hand, so the data lake is very complementary. In fact, where I think that the data lake comes in very handy, we talked about it a lot, is doing that ETL work, especially up front, to really kind of augment your data as it comes into Azure. Use your data lake to go out, get the conform dimensions, augment the data, write it back down to something like ADLS so that you can load your data warehouse and use your data warehouse purpose-built for serving up queries to end users. If you've had an appliance on-prem, if you've built a data warehouse yourself with SQL Server, Oracle, or what have you, one of the things that you've probably done a lot of is doing a lot of ETL work within your appliance or within your data warehouse environment. Stop doing that in the cloud. There's no reason for your SQL DW to be doing ETL. There are other tools in the cloud that are built for it, and what you should be doing is getting that data landed on disk that is ready to be loaded into something like SQL DW, and just load it. And then that way your SQL DW doesn't have to be, again, let's talk about sizing. You're not sizing your SQL DW to handle your ETL load. You're only sizing your SQL DW to handle your end users. Again, this is about purpose building, using each tool for what it does really well, and having those tools, even though they might all be managed services, having those tools do the thing they do well and then pass the data downstream to the next user. It means that you have to use more things, but what it means is that you have a more robust application that is really set up to handle a lot of data in a parallel fashion and really kind of serve that data up to your end users at the cheapest cost to you. And that's really important because that's how you can continue to build additional applications as you need them. So I talked a little bit about them complementing each other. The data lake world on the left allows you to ingest that data, clean it, catalog it, even do some advanced analytics and ML against it, and then move that clean data to SQL DB or SQL DW for all that structured analysis that you need. And then finally, on the SQL DW side, one of the things that I would say is definitely use Polybase. So when we talk about what Polybase can do for all that work, as I've talked about doing all that ETL work sitting in the Hadoop world, and then landing that data into a structured file such that it is ready to be loaded into your SQL DW world. Now, if you're using Polybase, you're able to load that data in parallel into SQL DW in such a way that it takes a lot less time to run than if you're using Azure Data Factory or BCP or something else. So by using Polybase to basically look out over those files and folders sitting in your big data solution, you can create an external table over them. You can either bring that external table into your world, or maybe even just leave it out there in the big data solution so that you can extend it out so that you have your data, maybe a subset of your data sitting in SQL DW with another superset of your data sitting out in the cloud, so that you can use both for their purpose-built solution. So what about Spark? I haven't talked much about Spark. And when we talk about big data, generally speaking, people want to talk about Spark today. And I've kind of left this at the end because it has the promise of doing everything in one place, right? Who here has used Spark at all? A couple people. So Spark is the newest darling to the big data world, which allows users to basically do many of these things at the same time. In Azure, we absolutely have Spark available in HD Insight. So when you build an HD Insight cluster, one of your choices is to be able to do Spark on Linux. And in fact, this week, Maxim was here and he announced that Spark 2.0 is available, which is significantly faster than Spark, the previous version of Spark, significantly improves your ability to write SQL queries within that environment, makes streaming a lot easier. So it's definitely something to talk about. What it does is basically your data sources like Azure Data Lake Store or Azure Blob Storage, they're on the bottom, and then you have the Apache Spark cluster above that. And that gives you the ability to do your language like Scala, gives you the ability to do SQL queries in that. And what they build on top of it is basically these modules like Spark SQL, Spark Streaming, ML Lib, so that you can do all of those things within one environment. And the thing about Spark is it caches data so that it really improves your big data performance, giving you the promise of being able to do interactive queries, being able to do batch, being able to do streaming, all of that within one tool base, within one application, within one cluster even. And there's a lot of promise there, and that's all good. And I have nothing bad to say about it. I would say it's probably the equivalent of SQL Server on-prem in that it does everything pretty well. In fact, it's gotten better over time. But that doesn't mean that each one of these things is better than some other purpose-built solution, right? So the reason why we use SQL is because a lot of customers will use SQL, they use SSIS, they'll use analysis services, reporting services, because you bought the license. It's all in one environment, it's all really well and good, and it works for you, and that's fine. And if Spark does all of that for you really well, then I would say absolutely use Spark. On the other hand, a lot of times, there are other applications that might be better for a particular thing. On the on-prem world, a lot of people use Informatica to do their ETL work, right? A lot of people use Tableau on the presentation layer. These tools oftentimes are very special built and do things that, the one tool that tries to do everything, they'll do them a little better or a little bit differently that maybe matches your needs better. The same cases here as I see as Spark. Spark does everything well. It might satisfy a lot of people because you can do everything in one environment. But if you really want to talk about robustness and be able to grow and be able to have that modularity that we've talked about, this might not be the right application to do everything into. For example, when you talk about Spark SQL is a second-class citizen in Spark compared to something like Hive or even ADLA, where both of those applications were written with SQL a little bit more in mind. When you talk about Spark Streaming, it doesn't have near the robustness from a streaming point of view that either Storm or Azure Streaming Analytics have, especially from an ease of use for Azure Streaming Analytics. Machine learning, there's only a few libraries in Spark that are truly parallel compared to something like R, which you could use in HD Insight also. So like I said, it could be a solution that works for a lot of people, but it's not a one-size-fit-all for everybody. If you are going to be using Spark, it's definitely very interactive on small data sets. If you have a relatively small data set, let's think in the gigabytes or even small terabytes, this could be the solution for you where you can do all of that in one place. You can put Power BI on top of it. You don't even have to build a separate interactive layer, and it might just work just fine for you. On the other hand, if you're looking at larger data sets, you're going to definitely need some larger clusters with lots of in-memory, SSD caching, and even then, you may have to think about what else you can do to push data down into another interactive layer to really serve your end users, or maybe use another interactive layer to serve off a subset of your end users. because you might want to just push off one group of people into some other tool like SQL DW while your data scientist maybe access your Spark data. And then one of the things that can be really helpful is going back to old school, which is Spark has the ability to do built-in sampling. And so when you talk about doing ML, for example, ML for years was done over sample data sets. If you find that you have a large enough data set that it's really causing your Spark cluster to have some performance issues, think about built-in sampling as a way to kind of get around that and still get the kind of ML that you need to do on top of sampling. So what does it look like if we put it all together? Putting it all together, we could have a base architecture, an introductory architecture. Your first big data solution might look something like this, where we're pulling data into Azure storage, and we might be doing HDI on top of that with some machine learning, and then eventually pushing that out onto Azure SQL for some Power BI. And that's where a lot of customers start, right? Is just get that data in, we're going to use it for some ETL, push it out into SQL DB and Power BI on top of that. But later on, you might do something a little bit more complicated, which now we're looking at more of a Lambda architecture. We're on the bottom, we're dropping data into Azure Data Lake Store in a batch process. We're using Azure Data Lake Analytics to do some processing on that and write some data back to Azure Data Lake Store, but also maybe out to blob storage. You might have an HDI cluster, it might be running Spark or something on top of that, doing some machine learning. But at the same time, at the top, you have some data coming in through event hubs from some applications, like an IoT application. You're doing some streaming, you'll have to write that data down to blob storage. Maybe you're calling out to machine learning while you're doing that streaming. And then you're driving your Power BI dashboards not only on some of the streaming data, like you saw in the application earlier, but also driving that out of maybe Azure SQL and maybe even SQL DW down at the bottom to really kind of push the envelope on your Power BI dashboard. Your Power BI dashboard will oftentimes have data coming from multiple sources. And then finally, talk a little bit about leveraging Azure Managed Services. You might have seen this slide in the past, and I think it's really kind of important in this space especially. Where you want to be is as much green as possible. When you talk about HD Insight, it's a platform as a service where Microsoft is managing the cluster, the OSs, the patching, and everything for you so that you can just focus on what you really need to be focused on as a data professional, which is focusing on the application, the data, and your end users, not focusing on building up clusters and managing them and how many you need and expanding them over time and all those kind of things that come in with running either on-prem or as an infrastructure as a service. So we talked about those four things. What that can mean is you can end up with an application like NEC's, which is fairly interesting. NEC built an application on top of Azure that allows them to basically take with some video services within their retailers, be able to get some real-time look into the demographics of who's in a particular store. So these video streams can basically analyze through ML, through streaming and ML, the gender of the people in the store and the count of the people in the store so that they can get an idea of what the demographics of a particular store look like so that they can run promotions. And they're doing all that in real time, storing the data, and then looking at how those promotions over time, whether or not they succeeded or not. And that's more the batch on the back end, right? So you have the streaming part of, hey, we have these people that are in the store. We know that there's a bunch of males or a bunch of females, and there's 24 or 50 of them. We're going to run this promotion for the next half an hour and blurt it out over the intercom or what have you. And then later on, what you want to see is, okay, after we ran that promotion, the batch part of it is, how did it work? And then you need to run and then feed the ML models based on that information so that you can drive additional information. And so what you end up with is a pipeline flow that looks like this. Allows you to think about your ingestion and always think about, well, first let's deal with the bulk ingestion, getting our data into our data lake environment. But then eventually we want to start thinking about our streaming and our event ingestion so that we can really kind of get those more robust applications going downstream. And then finally, when you think about your people that you're actually serving up to, think about two different things you need to think about. One is your data scientists and your other business analysts, how they're going to access the data through something like Azure Data Catalog, or being really smart about how you label folders within your data lake store, and the applications you're going to give them, but also think about how you're going to serve up a visualization layer that is just as quick and as your users are used to, and that's probably going to require some sort of interactive environment. And then here's some free IT Pro resources available for you if you're thinking about looking at any of this stuff. And then after that, what I would say is I have a few minutes for questions. Otherwise, I appreciate everybody coming. Thank you for staying late on a Thursday afternoon. And everybody have fun at the party tonight.